Yo, what's up? So as you can see, it's a very simple problem that consists of only 17 lines of code. So the challenge isn't really coding it, it's just getting the logic, which I will draw for you, if you don't mind. So let's pick out a random tree. So let's say we have a root, we have any random layout we can add, children as much as we want, let's say something like this, and like something like this. Okay, so we want to iterate over every edge, so basically every pair like this. So we can have like those two, or those two, or those two. And we want to know all the possible paths between two nodes in our tree that pass through that edge. So let's consider any edge, like for one example, this one. So let's enumerate a few paths, like first this one, then you have this one, and this one. Or let's say we start from here, then we would have this one, and this one. I can keep going. We have to use that edge, so like that, and etc. etc. Basically what I'm trying to get at is the number of possible paths using this edge is the number of, let's say, nodes on that side of the tree. So it can start on any of those nodes, and the path must end on any of those nodes. And then it's like it's a pure combination problem, like it's more a product actually. Like the number of possibilities on this side, it's not even DP, it's simpler than that. Just the number of possibilities on this side times the number of possibilities on this side it will give you the total number of combinations. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So basically, in this case, the answer would be 3 times 1, 2, 3, 4, 5, 6. 3 times 6, because there's 3 nodes on this side of the edge and 6 nodes on this side of the edge. So now the challenge would be, how do you get the number of nodes on this side and the number of nodes on this side? Well, since we're using a tree, or we're working on a tree, we know that the number of nodes on this side is just the number of children of this end node. So we just have to count all the children. Let's say in this case we have 2 children, and you add the +1 in the end for the current node. So the number of children including the actual node. So we have one part of the solution. Then the second part of the solution is all those other nodes. But you may notice that this part of the solution is just like all the nodes minus the nodes we found on this side. So if we have the number of nodes in our tree and the number of children of the end node or edge, then we can find this part and find the answer. We just do the product of both parts. So we can look at the code that does exactly this. So here I build the adjacency, alright? Here I get the node count by iterating over every edge and putting every unique node that are used in edges in this variable. So that's our total node count in our tree. Now here I have the function that counts the number of children for a given node. So basically it's just the sum of the children count for every child plus 1 to include the current node. To include the child actually. And then I iterate over every edge and I count the possible endpoints, so this side here. Then I find the complement, so this is the complement, or the starts, the possible starts, and so this is the ends, and this is the starts. And you just multiply them. Like this. So here I have ends equals children count of the end part of the edge plus 1, and then we take the complement of the total node count minus ends, and then we add the product of both to our answer. Makes sense? Any questions, class? I'm actually gonna... Like after the stream's over, I think I'll like clip this part, like upload it to... Why are we using LRA cache? Okay, so... If we're asking the question, what's the total number of paths going through this edge? Well, we have to count the number of children of this node. And that's going to be the total number of children of this node, this node, this node, this node. So if ever in the future, like, we ask the question, what's the number of total paths going through this edge? Well, since we already computed it when we ask this question, we memorize the result of the recursive call. So basically, instead of having to count all the children every time we do a query, we just compute it once for every node. So what that does is that the algorithm is in order of number of edges plus the number of nodes in our tree. Makes sense? Let's look at bunnies. Oh, it's reworking. Perfection. Ah, yes. There we go. I should come back to... Wait for it. Wait for it. I think I lost it. Okay, let's do it again. So if we have... Oh, Roger Nadal is following. Oh my god, it's the first time anyone has ever triggered that alarm. I was a bit startled. Sup, dude? So I think I'm gonna use this as a thumbnail. If only I could zoom like halfway and not all the way through. Like this. Perfection.